Matrices are used in demand models to store zonal interaction data. There are primarily two kinds of matrices: the supply-side matrices called skim matrices and the demand-side matrices called OD matrices. Skim matrices store travel impedance data between various zones. The travel impedance may be either travel time, distance, or some composite value represented by an impedance function. In case of a PUT model, it may also contain information such as number of transfers, number of zones traversed, etc. OD matrices, on the other hand, store trip or OD demand data between zones. OD matrices are inputs for highway or transit assignment, whereas skim matrices are inputs for trip distribution. In VZoom, matrices may either be calculated within VZoom or imported as pre-calculated values. When storing VZoom matrices on disk, the user may specify various formats in which to store a matrix. In order to explore these file formats, click Demand, Matrices, select a matrix, then click Edit. This will bring up the VZoom Matrix Editor. In the Matrix Editor, click File, Save Matrix As. Select the directory for storing this matrix file with an appropriate name. Then click Save. A new dialog window will appear. In this dialog window, click the Matrix Output tab and then click the drop-down list box under the matrix formats. This will display a list of various available matrix formats available for storage of matrices in VZoom. Let us explore one of these matrix storage formats. In order to do this, select a matrix format of interest from the available matrix formats. Say $V VZoom Standard Format and click OK. This will save the current matrix on disk in the specified format. Now this matrix may be opened in any standard text editor. Open this matrix in Notepad or TextPad and take a look. Any other VZoom matrix format may be explored in a similar manner. The matrix format consuming the least amount of disk space in VZoom is the binary packed format. Since this matrix is in binary format, it cannot be edited in a standard text editor. As seen in the previous section, VZoom matrices may be manually edited using the matrix editor. There are two ways of navigating to the matrix editor in VZoom. In the first method, go to Demand, Matrices, then select the matrix you want to edit and click Edit. This will open up the matrix in the matrix editor. This method is used when the matrix to be edited is already present in the version file. In the second method, go to File, Matrix Editor, Open Matrix. Browse to a matrix file stored on disk, select and click Open. This will open the matrix in the matrix editor. This method is used when opening a matrix file stored on disk. Once a matrix is open in the matrix editor, the values in the matrix may be interactively edited by the user. Also, the user may perform various operations on a matrix in the matrix editor. Let us perform some basic matrix editing. To edit a single value, click a cell and type in a value and press Enter. Another alternative to this is to right-click on the cell of interest, then go to Edit Values. Here, there are two options: Projection and Set Value. The projection option allows the user to multiply the existing cell value by the projection value entered. Set Value allows you to enter a specific value. In order to edit multiple cells, the user may select multiple cells by clicking and dragging the mouse over multiple cells. Now right-click and select Set Values. Enter a value and click OK. All cells will have the value you just entered. If you wish to enter a projected value, you may follow the same procedure and select Projection instead of Set Values. The user may fade out certain rows or columns if editing only certain values in a matrix. This keeps only necessary rows and columns visible. In order to fade out a column or row, select the row or column by clicking under the zone, right-click and select Fade Out. In order to fade out both row and column, again, click a row or column, right-click, and select Fade Out Row and Column. We now go over some elementary operations that can be performed in the VZoom Matrix Editor. These operations can be performed by using the associated icons in the bottom part of the VZoom Matrix Editor. To set the value of an entire matrix to a specific value, click the equals to sign, enter a value and click OK. To change the type of matrix, click T. Now select the matrix type, double, float, integer, etc., and click OK. To perform an addition to the matrix, click the plus icon. To add another matrix of same dimension in a cell by cell manner, select the matrix file to add and click OK. In order to add the same constant value to the entire matrix, check the Enter Value box, then enter a value to add and click OK. Other basic operations like multiplication, cell by cell, subtraction, and division may be carried out in the same way as addition. To take the reciprocal of a matrix, click the 1/x icon. To take the log of matrix cell values, click the ln x icon. To raise the matrix elements to a power, click the x to the power of a icon, then enter the value of the power and click OK. The max and min operations allow the user to set maximum or minimum of cell information. To take the maximum of a formation, click Max and select a matrix for cell-by-cell evaluation, or enter a single value to cap the matrix value to a constant. The value retained after the operation in the matrix will be the maximum of the value in the matrix cell, and the selected matrix value, or the one entered as a single value. For example, if the matrix cells contain 10 and the user enters 5, then the retained value will be 10, since 10 is greater than 5. In a similar way, the min operation will keep or retain the minimum of the value entered and the one existing in the matrix cell. The Set Diagonal option sets the diagonal of an active matrix to a user-specified value. The Extract Diagonal operation keeps the existing diagonal values as they are in the matrix and sets all other values in the matrix to 0. Elementary operation also allows the user to reflect the upper triangular of a matrix into the lower triangular part of the matrix, or reflect the lower triangular elements to the upper triangular part of the matrix. The brackets to the power of t operation evaluates the transpose of a matrix. Once the required changes to a matrix have been made, the changes may be retained in the existing matrix and taken back to VZoom. This can be done by clicking File, Export Matrix to VZoom. By default, if a matrix editor window is closed, VZoom will display a dialog that allows the user to either take the changes made to VZoom or to retain the original matrix without any changes. The user may also save the modified matrix to a file by clicking File, Save Matrix As menu. The VZoom Matrix Editor allows for various types of advanced operations on matrices. These operations may be used for analysis of matrix data or in performing various calculations related to matrices. Let us go through these advanced operations one by one. First, we learn how to set a matrix filter. Matrix values to be filtered by definition of intervals, values belonging to such intervals or bins can also be drawn with a specific color classification or coding. To create a filter, click the Filter Range icon. In the space where 3 columns show up, right-click and click Add. Define the lower limit and upper limit here and allocate a color coding if necessary. Then click OK. The user may create any number of bins as required. Once these bins are created, the values in the matrices will appear color-coded as per definition. Any value not meeting the filter criteria is tagged as passive. The user may also edit values meeting a certain filter criteria. In order to do so, click the Replace All Filtered Values icon. Specify a filter criteria, say lower limit 0.1 and upper limit 1.0. Now, enter values to replace the existing values with. Checking the checkboxes against the new values will result in new values being placed in the matrix cells meeting the filter criteria or not meeting the filter criteria, as the case may be. If the checkbox is not checked, a replacement will not take place. The matrix editor can also be used to interactively aggregate matrices. To use this feature, click on the Aggregate Matrix icon and select the type of aggregation to be performed. Most commonly, it will be an addition of values. Then click Add. The zones to be aggregated must now be defined one by one. To do this, from the list of available all zones, select the zone to aggregate by clicking the zones in All Zones and then clicking the Back icon. Then click OK. This will put the defined zones in the list with new zone numbers and old zone numbers being aggregated. Once the required aggregation has been defined, click OK. A new matrix with the aggregated zone values will be displayed. The projection function in the matrix editor allows a user to project a matrix in various ways. One is by either applying a single projection factor to an entire matrix or by projecting the entire matrix to a target value. Another way of matrix projection is by specifying a target values or projection factors for production and attraction totals, or row and column sums. To perform a matrix projection on an entire matrix with a factor, click the Projection Of icon, then select Projection of Entire Matrix and check the Factor option. Enter a factor and click OK. To perform a matrix operation on an entire matrix with a target value, click the Projection Of icon, then select Projection of Entire Matrix and check the Target Value option. Enter a target value and click OK. To perform a projection based on row and/or column totals, click the AN option from the Projection of Constraints. To balance by row totals and factor or target values, click Singly Constrained Production. Then double-click the zone line and enter a factor or target value as required. Once a value has been defined for all zones, click OK. The active matrix will be projected with the defined constraints. In order to perform a similar projection based on column totals, click the Singly Constrained Attraction option and follow the same procedure followed for the production constraint projection. If both production and attraction target values or factors are available, then the doubly constrained procedure may be used. In order to do this, click the doubly constrained option in the matrix projection dialog. Select by target value or factor. Select a balancing method for the matrix balancing. Mean of both sums is a frequently used option. Now, specify the number of balancing iterations and quality factor. It is best to leave this to default in most cases. Then enter the production and attraction target totals or factors and click OK. The active matrix will be balanced using both expected row and column totals. The matrix editor can also be used for calibration of gravity model coefficients by using an observed trip length frequency, observed production and attraction totals, and a skim or impedance matrix. The model allows for estimation of coefficients only for a combined functional form of impedance. To estimate the coefficients of a gravity model, first open the calculated skim matrix, then click the C icon. Enter the observed production and attraction values for each zone. Click the Input Distribution tab and enter the time bins or trip length frequency for the observed input distribution. Click the Options tab, select a functional form for the model, Select either a singly constrained or doubly constrained procedure for balancing and click Calculate. Check the results in the Results tab. The A, B, and C parameters will be displayed under the Results tab. Lastly, we shall learn how to classify or create histograms of matrices in the matrix editor. To classify a matrix, click the histogram icon in the Classify Intervals menu. Click Add in order to create bins by entering a lower limit, an upper limit, and an interval length. The intervals may be marked as inclusive or exclusive by clicking the appropriate checkbox under the interval type. Once the intervals are defined, click Settings and check Option 1 if the histogram is to be created for the loaded matrix, and Option 2 if the histogram is being created for a matrix stored on the disk. Also, browse and select a matrix in this case. If you wish to save the output data, check Class Allocation List for saving out interval or bin information, and check Class Matrix to save out the classified matrix data. Go to the Graph menu and click Classify. A histogram plot will be displayed showing the classified data according to the intervals specified in the Intervals tab. If you wish to use the same classification multiple times, the settings may be stored in COD format by clicking Save and giving the file a suitable name. Other matrix operations, such as application of a Box-Cox transformation for normalizing matrix data, etc., may be used in much the same manner as multiplication or addition functions in the matrix editor.